Okay, I think we should just get started. We are less audience today.
We should start it. Yeah, might as well get started.
Okay. So today I'm going to talk about my PhD work, basically on attention and engagement over multimodal dialog systems. So I'm from Language Technology Institute, advised by Alan Black and Alex Rudnicki. So this is, I'm proposing my thesis topics next month. Oh, okay. I'm proposing my thesis topic next month and hopefully could graduate in a year. So first of all, let's take a look at the previous dialog systems that existed. So we know the AT&T customer-based dialog system, the Jupyter in MIT, the Let's Go system in CMU, and also the Cambridge Information Dialog system that gives you restaurant information. And also Siri from Apple, which is a personal assistant, which appeared in 2010, and Google Now for Google, which has a predictive power, which created 2013. People think it's a little creepy sometimes. So Microsoft Cortana is promised to be able to talk about everything with you. It created 2014. And then Amazon Echo, which is an embedded device that with dialogue capabilities. It is created in 2014. So apparently, the dialogue system has moved up to a more industrialized, more commercial way. A lot of big companies are doing that. So a lot of people think it's a solved problem, but no, we're far away from solved. So a lot of these systems can do certain tasks and can complete certain tasks like information query and giving. So my motivation of this is, first of all, is this conversation task the only thing that we care about? So if we look at humans, when humans talk to each other, we focus on the task, but we also have this channel maintenance going on. So it is not only the task that actually matters, also the relationship, the bonding that matters. So it's not only about this information request or information received that it matters. It is actually the social bonding that also comes into the conversation. So my research comes from this human-human conversation aspect. How can we adapt to user? How can we actually care about the user? And also, how can we make the conversation natural and effective? So we all know that when we talk to each other as a human, that we notice different verbal and nonverbal behaviors humans express. So we're trying to accommodate these behaviors. We can infer the internal state of the human. So what we are trying to do is that can we teach the robot, teach the dialogue system to do the similar thing? So particularly, we think that in a conversation, I care about attention, which is a frame by frame aspect. Are you paying attention to me right now or later? Also engagement, it's a connection between two people. So do we have this connection? Are you engaged in the conversation? So first of all, I will talk about the first work that I've been doing, which is attention-based. So first of all, we can see a robot. It's a physically situated robot that can give you directions.
Morning. Can I help you find something?
Yes.
What room number are you looking for?
Conference room 3800.
To get to conference room 3800, go to the end of this hallway. Turn right and go straight down the hallway for a bit. Conference room 3800 will be the first room on your right.
Thank you.
You're welcome.
So where can I find John Doe?
John Doe is in office number 4120. To get there, take the elevator up to the 4th floor. Turn right when you exit the elevator and continue to the end of this hallway. John's office will be in that wing of the building.
Thanks.
No problem. Bye-bye.
Next time I should try Bill Gates. Maybe better. So this is a demo of the robot giving the directions. It looks perfect. But what does reality look like? This is a robot's view of the human.
Directions. Sorry. Say that again.
I'm looking for my meeting.
You said Matt McKinley, right?
Oh, give me a minute.
Sorry. That was Alberto Bacalai you wanted. Correct. Well, guess I'll see you later.
So we have found unsolved problems. So, so we look into the literatures to see what is these. We look into the literature in Charles Goodwin, and we find that people have a lot of disfluencies when they speak to each other, and we see why they're doing it. If we look at the other partner's gaze, we find this interesting coordination. So the red dot is not attention not on the speaker, and the solid line is their attention on the speaker. So we see that people are using these disfluencies to track the conversational partner's attention, which is very interesting. People are doing this. Anyway, we went to bed. So we think that disfluencies are not merely a cognitive error in production. It is actually a conversational strategies that people use to attract the other human's attention. So we see that Goodwin found that people are trying to achieve mutual attention in the term beginning. So a lot of people are using this. She's reaching the point. She's reaching the point, and so people use a lot of disfluencies, restarts, and all these pauses to attract people's attention. People go through a lot of troubles to try to get the other people's attention. So we think, can the robots do this? So we think of a recipe for letting the robots do the same trick. So we first of all identify the user attention targets. Then we try to predict attention targets automatically for the robot. And then we design a policy so that the robot can accommodate users. So first of all, let's see what are all the users looking at. So we collect the data, a set of data using this physically located robot in a hallway. So people can just walk up to it and talk to it. So we ask the human to actually annotate where the user is looking at. So we find our distributions, and we have a coding manual that we care about, that is the places that we care about that is related to the task. So we find people mostly look at the robot, people look at the robot pointing the directions, people look at the other people's, and people look at the badge reader because we ask them to swipe the badge. And then people are also looking at their walking directions when they leave, and the others are in the other category. So we say that we have all these labels, we have all these supervised data. Now we can do machine learning now. We have the features from the human pose direction, like facing to the left, right. And then we have raw features from the face recognizer and the face tracker. And then we have the dialogue states, which is very useful. For example, we only in this direction giving dialogue state, the robot is going to point. People are going to look at the pointing direction of the robot. And then we use simple classify, logistic regression or boosted tree to classify these. It's a multi-class classification problem. So we find the model can now do a 0.28 in average error rate. So it seems like we can get 70% right for attention targets. Now we say,
Hold on. What
Yep.
about the prior?
no, the prior is bigger. because you couldn't really say that everybody's looking at the robots.
So if you just said everyone was always looking at the robot, wasn't that 70%?
No, it's the average error rate. So it's like it's calculated differently.
Oh, I see. So it's a detection test.
Yes,
Okay.
yes. So we have the recipe. We already identified the attention targets. We have the prediction for attention targets automatic. Now we need an attention policy to let the robot to do it, because now we have the signal. How can we use it? So come back to the goal of my my entire work again. We want the conversation to be natural, to be effective. And then we say that how can we achieve this? We think if we accommodate users' attention, then we can achieve this goal. So we have two planning elements, which is user attention supply and system attention demand. So the user look at the robot or not, it's a supply. The system attention demand is based on, is this task for different dialogue state? Do we have the demand of the human looking at it? For example, when we are given directions, we want the human to pay attention. If we're saying hello, goodbye, that's okay. And then we have two planning points. The first is at the beginning of this phrase, and the second is throughout the phrase, which is the end of the phrase. So due to the literature that we draw from Charles Goodwin. So we say that we use these elements, these planning points, and we want to combine the task content and task dialogue context to plan this. So this is a policy we designed. So the red arrow means no user attention. The black arrow means has user attention. So we are at this current phrase beginning. If we don't have user's attention, we pause. If we still not having it, then we say, excuse me. And then we pause again. And then we launch two words. And in the end, we pause if we still don't have our attention. And then we launch the phrase again. So we say, excuse me, to go to room for 4300. So whenever we have attention, we go to the last stage.
Oh, sorry. So the attention is determined by the gaze?
Yes.
Only by that modality? So what if they're listening and they're...
Yeah, that's a great idea.
Looking down a lot, but he's perfectly tracking what's going on.
Yes.
Yeah, I perfectly track.
I totally agree with you. We have this distinction between cognitive attention and the visual attention. So right now we're only considering the visual attention. Yes, we have seen people sticking their ear out and trying to listen, and by not looking at the robot, but he has full attention on the robot. But right now we are not only considering the visual attention.
Okay, thanks.
So an example of me talking to the robot.
Eric Corbett office in 3126. Eric Corbett office in 3126. To get there, walk to the end of the hallway. Turn left and walk to the end of the corridor. Eric's office will be the last office on your right. By the way, I'll let Monica, the virtual admin, know that you're on your left.
So actually people do this a lot when they are looking at the other partner in the group. So we also do another thing is that by the end of the phrase, if we also calculate how much attention throughout we have obtained from the user. If we don't have enough attention, we pause and then repeat the previous phrase. Whenever we have the attention, we reduce the length of the pause. So we only repeat once because repeating too many times actually makes the user very annoyed by the robot. So we have an example of being
To get to conference room 4800, take the elevator up to the fourth floor. Take the elevator up to the fourth floor. Turn left as you exit the elevator and keep walking along that hallway. Turn right and continue on down the hallway. Conference room 4800 will be the first room on your right.
Wow, that's almost kind of freaky, isn't it?
So we wanted to integrate some future strategies like self-correction. Turn left from that corridor. From that corridor, turn left. Listening. turn left from that corridor. Should be that corridor. And then from nonverbal behaviors like, hey, you, look at me. Robots can do that. And then we have a plan for the evaluations. So we want to see that did robots with attention shaping model get more attention in the end? And we want to bring a third person to see that if the human observers think that the interaction with more attention is actually more effective and natural. And we want to evaluate whether the attention shaping robot is more natural and effective to interact with. So we wanted to do the A/B test and with a questionnaire. So it's actually a framework that you can adapt to any conversational system with multimodality availability. So the recipe is simple. Determine the attention targets that the system carries in the dialogue context, and train a machine learning models to automatically predict the attention target. And in the end, you adjust your attention shaping policy parameters according to your specific task, your task content, what kind of dialogue state you think are more important to you, dialogue context, the switching of the task. Do you care about people to be on task all the time, or some of the utterance you think it's okay for people to ignore? So this is a better demo that I made for a paper.
Do you need help finding something?
Yes.
Could you tell me the room number or person you're looking for?
I think it's 4,800.
To get to 4,800,
I think it's 43. Yeah.
excuse me,
43.
go along that hallway.
I'm looking for 4,300.
4,300 is just down that hallway and will be the first room on your left.
Okay.
By the way, would you mind swiping your badge on the reader below so I know who I've been talking with? Can I help you find something else?
No, I think that's it. Thank you. Bye.
Okay.
Bye.
Bye-bye.
So this is a view of the robot. The red dot is the robot's gaze. So the gaze would actually shift when he is pointing.
Something.
Yes.
Could you tell me the room number or person you're looking for?
It's 4,800.
To get to 4,800. Excuse me.
Tracker.
Go along that hallway.
I'm looking for 4,300.
4,300 is just down that hallway and will be the first room on your left. By the way, would you mind swiping your badge on the reader below so I know who I've been talking to?
So we have some of the more explanatory of what things going on inside of the robot. So at this point, we pause because we lost the attention from the user.
Excuse me.
Excuse me. And we still don't have the user's attention.
Is it just attending?
It's actually a machine learning detector. So it uses the face feature. So the direction of the face feature is inside of. Yep.
4,300 is just down that hallway and will be the first room.
No, it's not picking up the hand gesture. Yes. 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 So these are real humans talking to the robot. There's no script.
Excuse me. 280 will be on that side of the building. Excuse me. Can I help you find something? Good morning. Do you need directions? Excuse me. Do you need directions?
It's very fun to watch real human interacting with it. So these are some of the failure cases. So it's not perfect. It's not. Yeah, that's
Excuse
great.
me. Sorry, you wanted 3866, correct?
That's right.
Excuse me. To get to 3866,
We got too
go
close.
to the
We
end of
lost
that
it.
hallway. Go to the end of that hallway. Keep on walking to the end of the corridor. Keep on walking to the end of the corridor. Turn around. Well, guess I'll see you later. By the way.
So this is a
one of
multi-party
you guys
case.
mind swiping your badge on the reader? Got it? Excuse me. Next heading.
And the other thing is that sometimes people walk away, they thought the pause is the end of the utterance.
Chris J.C. Burgess' office is 3,928. To get there, walk to the end of that hallway. Oops. Well,
He didn't wait till the end of the dialogue. So we have some of the problems that we want to solve. So it's far away from perfect, but at least it can do something to regulate users' attention. So after talking about attention, the other thing I really care about is engagement. I used Kenny Seitner's definition for engagement. Engagement is the process by which two or more participants establish, maintain, and end their perceived connection during interaction they jointly undertake. So we think that engagement is a process. We actually want to study the process. So how do we study the process? We come up with the plan saying that all these dialogue systems are completing certain tasks. How do we, but actually we care about this social engagement, this conversational engagement. So we actually isolate the task factor. So we get rid of the task. We say we only do chatting, social chatting, the bonding. So we build a non-goal oriented multimodal dialogue system called TikTok. I have been working on it for a long time. So it feels like TikTok is my baby. We have several goals. We want to keep human engaged in the conversation as long as possible. And we want to make human enjoy the conversation experience. We want to know that how can we isolate, so after isolating the task, we focus on the social part of the conversation. How can we learn the engagement in this setting? And then later we can apply to other, collaborate it with other tasks. So it is an iteratively improved system. So first of all, we design and deploy our initial TikTok. So a lot of people use wizard bots, but we are not using it. A lot of people are using generated synthetic data. We are not using it. So what we are using is that we first design an initial model, and then we deploy it and collect data. Then after the collected data, we annotate the data for engagement and trying to train computational models for engagement. And then we also discover engagement strategies, how to bring human to be more engaged. And then we say we deploy the engagement-aware TikTok. And then we also have a human data that actually gives input in the training process of the engagement model. Then we iteratively modify our engagement model to use the collected data. So this is an iterative process. But first of all, let's see what TikTok looks like. So it is a dialogue system. It has all the components that a dialogue system has. So we use a Google ASR because it is an open domain dialogue system, and I have really good experience using it. I find it's tolerable. So after we do the ASR, we feed it to our natural language understanding components. So we do POS tagger, then filter out the stop words and get the keywords. And then with reweighting, we go into the content retrieval part. So for content retrieval, we have two models. First is the TF-ID of weighted keywords matching in database. So we have a database of interview transcripts, so which is a Pierce-Morgan show. So we have extracted question-answer pairs. So we use the keywords to find the most similar utterance, and we return the response of that utterance back. The other is the Reddit. So we use the Reddit API to query the Reddit and find the most similar match. Then we figured out the dirty words and name entities and then return that. So the other thing is the conversation strategy section. So we have a retrieval confidence from the previous step. So how actually, which is like a weighted weights. So if it is bigger than certain threshold, we have two strategies where we randomly select from. We just answer it, return the response to the user, or we continue with an open question. What do you think? And if it is smaller than certain threshold, which means that we don't have a really relevant response to it, what we do is we switch a topic, or we end the topic right now and open up a question. So switch topic is like, do you like movies? So we have certain topics that we have in our database that we actively switch to. So the natural language generation is template-based natural language generation. We have 4 strategies so we have 4 templates. So example is like, I can't answer this. What do you think of music? So in the end, we have a talking head. It actually communicates the internal state of the user. So Alan said that I can't have a robot for my thesis work because they always break and I will never graduate. So my good friend Ashish drew this kiosk for me. So it is a GIF file. So once the speech synthesis starts, then the GIF file starts play. So it looks like the agent is actually speaking and doing lip sync. People are very naive. They think they are doing a lip sync. So this is an example of the TikTok with the base model that I introduced with 4 strategies.
Let me see. Well, it's a double-edged sword. Can't you share some interesting stuff with me?
Your nose is a question mark. I think that's interesting.
Of course. What's your idea?
I think it fits you perfectly.
Let me see. His nose is still broken.
Do you want me to make your nose broken?
Yes. Why did you ask me for this?
Because I thought you might mind.
Well, I'm not getting into specifics about what doctor treated him, how he was treated.
You haven't been treated yet. That's in the future.
Let me see. By the way, are you interested in movie?
So
yes, I watch movies sometimes.
Well, you know,
So you can see there are several strategies inside of the dialogue, and it's fairly open-ended because we're doing simply a retrieval method. There is no templates. So there are bad times and good times. So now we say that we have the base model. We collected data. Now we can actually analyze engagement. So what is engagement? How do we annotate them? So there are different people studying engagement. And it's hard to say who is right, or there is never a right or wrong. It's all about your own definition. So Alan told me that define your engagement and go on with it. So I think that after we have the engagement, we can actually use it to regulate, to select different strategies, and then to accommodate users' engagement. So we collected a database of people talking to TikTok. And you can see there are with mixed ethnicity, gender, English native, and dialogue system familiarities. So they are basically my friends. They come in, we ask them to talk to the TikTok as long as you want. You will get a cookie after that. So Alan also volunteered for my data collection. For a graduate student, we don't have money. So we define that engagement with Kenny Seitner's definition, and we have our annotation unit is by turn, and we ask people to label an engagement by turn. We have a 1 to 5 Likert scale, so we really care about if the human is actually interested in talking to the dialogue system. So our definition is more about the continuation of the dialogue. Are you interested? Do you want to talk more? So we have 2 sets of rating. We asked the participants to, after the interaction, to look at the videotape that we took and ask him to label by turn how engaged you are. And we bring up a third person, an expert, to label engagement as well. So it's actually very interesting that some of their, with different people, they're very different. Sometimes people are more expressive, sometimes people are less expressive. So this can actually give a bias. So the third person, which is the expert, can make a little bit error, deviate from the self-reported. So in order to study engagement better, we also include our analysis in a human-human conversation, which is doing the similar task, which is the everyday chatting. So it's also a database that native English speakers, they're talking about a movie and documentary stuff. So we want to see, can we compare the 2 data sets and draw some inspirations from the analysis of engagement and nonverbal behaviors so we can better design an engagement detector. So we have some of the verbal behaviors. We look at how many words are spoken in a turn. We find the more words you speak, the more engaged you are, no matter you're in a human-human context or a human-machine context. So here the refined and raw are refined as human annotation and raw is automatically detected. So for example, here word count is by ASR. So we also see that the faster you speak, the more variation in your speech rate, the more engaged you are. So we can see that definitely people are more engaged if they talk faster.
I'm just missing something.
Sure.
0.154 is the mean word. What does that mean? Mean.
The mean is at the mean of the word count.
No? Okay, but usually you have more words, so I don't understand.
Oh. So it's like the turn. So it's actually the count. So I should actually say the count of there.
I don't understand. So in a turn, let's say you have 50 words.
The number of words.
That's less than 1.
Oh, that's a correlation with engagement.
Oh, okay. That's what I missed.
I should have written
This
more.
doesn't tell us then about the actual rate. These are all correlation numbers.
Oh yeah, that's the correlation numbers. So Pearson correlation numbers.
Right. Correlation
between engagement rating and their number of words. It's actually, so because we have a lot of terms, so we think it's like above 0.1 is actually pretty good enough.
statistically significant.
Yeah.
Just I'm just saying it's not a big number.
Yeah, it's not a big number. We don't get really big numbers because they're not that correlated. So for the acoustic nonverbal behaviors that we look at is the louder the speech, the more change in speech intensity, the more engagement the user has. So we also use, so it's a speech processing that you can automatically get if in the end the raw features. And also the mean and variance of the pitch. Actually, we didn't find significant correlations in our data, but in other people's work, they are reporting that they have, it is positively correlated with engagement.
This might be a good question, but I mean, do you expect it to be a linear relationship? It means if it's not linear, you might want to look at mutual information.
You're right. So definitely you can't, you mean that if actually the two feature together has an impact?
Well, you're looking at Pearson correlation as being in the way that these things are covariant. If they're not covariant in a linear way, these two come from things, kind of numbers and maybe they're related in a non-linear way.
Yeah, definitely. So we actually use a kernel for machine learning methods. I guess that's sort of counts for the nonlinearity.
Yeah, I mean, so like if you look at a scatter plot of the two numbers, but it probably didn't look too much like a straight line.
Mm-hmm.
But it might look like a very tight curve.
Might look like,
yeah, I see what you mean. Yeah, it might be. We're only doing very simple correlations. Yeah.
Sorry, maybe I missed it, but did you say you normalized the pitch variance like per user?
Yep.
Okay, right. 'Cause I imagine that.
Yeah, definitely want to normalize to the errors. Yeah.
It's probably dramatic difference between different human interaction and machine.
Yes.
Why do you think it is?
So for different features, it's different. So for a human, they're actually talking much faster when they're talking to another human. And when human talking to a machine, it actually slows their speech. They think the machine is having a hard time to talk to hear. It's just like a human naturally do that.
Could that be related to the thoughts and machine responses?
Oh, that's speech.
In the previous
Yeah.
example, there were pretty long pauses.
Yep.
Processing pauses, I assume.
Yes, we have also analysis. We have also analysis on speech onset time. So we will get to that in next slides. Okay.
Sorry, I'm really interested in the pitch stuff.
Oh yeah.
Did you look at anything besides just the variance, like?
Yeah, I'm also thinking of looking at the main and max of the pitch. It might be some of the functionality.
Or like even more
functions.
complicated, just like I don't know, looking for a number of sort of like upward sloping, like rising intonation on word.
Yeah.
Like a count of like some discrete phenomenon like that.
Yeah, more intonation stuff. Okay, definitely. We also look into visual nonverbal behaviors. Apparently, more smile, more laughter, more head shakes, more engagement, both for human and for the machine. But one thing we find is actually there are very few head nods when people are talking to a machine. People just don't do the acknowledgement anymore, because we have this hypothesis because TikTok is not doing that. So the human is not doing that either. And because TikTok is a synthesized voice, we don't have this lengthening or decreasing in the end of our utterance that actually invites acknowledgement. So that's one of the guessing that we have.
I'm just wondering something about relatively small
Mm-hmm.
correlation. Is there some reason that you didn't do the Wizard of Oz stuff? Because I mean, it seems like that would have made your initial system a little more like.
I see what you mean. But yes, you can do Wizard of Oz. It has more control on the language and the understanding. But it's just more fun to do automated.
Oh, it's more fun.
Yeah, I definitely think that Wizard of Oz has more control. But it's also interesting to see that can we iteratively improve. And also definitely because this analysis are also giving us some of the feedback of the defects of the system that we need to improve on.
Right. I'm just thinking of one of the defects
Human to human, which are natural.
Yeah, but the system that the human. Oh, I'm sorry.
We have a human.
They're better, but they're still not great.
That's true, but they are a lot better.
Yeah.
Mm-hmm. So the other is the turn-taking behaviors that we mentioned. So we find that more time from the start, which means that over the time people get less engaged. So definitely the cuteness of the dialogue system wears off after a while. And also, but people wears off less. Speech onset time. Definitely. So this is an interesting twist that actually shows a defect over a system. So we see that for human, it's the less it's actually the less time you take to respond, the more engaged you are. But for human machine, it's actually a little bit different. So what we are trying to counterfact this problem is that we insert some disfluencies. So we say, what do you think? All these disfluencies to try to make up for the weight of this Google ASR. So interruptions, we didn't find significant correlations because interruptions have collaborative interruptions and interruptible, so that we cannot distinguish between them. Our dialogue system doesn't know. So now we have all the features that we extracted we think might be informative for our engagement detectors. So we select the one with correlation larger than 0.1 either data set. And then we do normalization, and then we try to build our support vector regression with our RBF kernel. So we do leave one participant. So what we find is that if we include the previous context of the conversation for up to 3 turns, we're actually getting a pretty okay correlation with the labels. So this is the results of predicting the current turn. So we can get a pretty okay prediction for current turn using the current turns feature. But actually what we want to do is a future turn. Can we predict the future turn of the engagement? So we think that we are probably okay. Right now we have 0.46. It's not great, but it actually gives you some correlation of how engaged the human is. So after we look into the data set, we think that we also wanted to know what kind of strategies that people use to engage human. So because our system is randomly selecting things out, so we actually can look into the data we collected and see when do the human engagement actually jumps up. And then we can see why the system actually stumbled on that is actually very useful. So we human coded these instances and categorize them into different strategies. So first is introducing new topics. Do you like movies? Yes, I do. What's your favorite movie? So the movies is actually something new that people actually want to talk about. And the other is initiating things to do together. Will you come to my friend's party today? No, you guys are losers. This is actual conversations from the data set. And the other is adopting famous movie scripts. Well, but what? You feel sorry for him? Don't bother. He was never fit to lead the army, and he certainly wouldn't fit to rule the galaxy. What's your idea? President said, I wasn't actually upset at the ruler of the galaxy, but now that you mentioned, I don't think he's doing such a great job. So it happens to be my friends. Most of them are CMU grad students. And then we have this adding humorous content. We should have gone after the handguns. What's your idea? I think we should go after the handguns. People are very creative and accommodating and making fun of each other. We have seen it. I'm not getting into specifics of what doctor treated him. You haven't been treated yet. It is in the future. So after these strategies discovery, after the prediction of engagement, we have these 2 signals. Now we can design a better system. So right now we're using a heuristic policy. It's that if the user is low for a while, then we randomly select a strategy. Then in the future, we want to do context-sensitive policy, which is what strategies we have been used before. And for this specific user, is this strategy effective? So we want to track these and do a more complex strategy planning. So I have a couple of future works I want to do. So first of all, the richer engagement strategies. One is possible like expressive speech synthesis. And we are also planning to look into some of social literatures to draw some of these variations. And then we also want to do better response generation methods. The long short-term memories we can use for response generation. Microsoft people are doing a lot of that. And we want to make TikTok web-based, so you can click on the link and talk to it through a web browser. And we want to make it a cloud-based, so that we can, a lot of people can talk to it. So this is another piece of work I'm doing with education testing service people, which is called Multimodal Dialog demo. It's a web and a cloud-based dialogue system. This is an architecture that I'm moving TikTok towards too. By their browser. So this is a funny interaction of me talking.
I'm Mark Coleman.
Talking
it's nice to meet you.
System.
Nice to meet you, Mark.
Long latency?
So, can you tell me why you're interested in this job?
It looks really great on the poster.
Could you talk a little about your education?
I'm doing my PhD in Carnegie Mellon University in Pittsburgh, Pennsylvania.
Okay, thank you. Now let's talk about your experience. Could you tell me more about your previous job?
I never had a real job. I interned in education testing service in Microsoft Research in.
It's an actual recording environment.
Now
It's the
I'm
kitchen behind me. And I have other bling
situations
bling
that
thing
you
going
might
on
come
in my
across at
background.
work, and I'd like to know what you would do in these situations. First, imagine that a customer calls to complain that their order is late.
It's a pizza delivery job. I never
Manager to
applied
handle the
for.
customer or offering the customer a refund?
Offering the customer a refund.
So
Hello, I'm Mark Coleman.
it's basically.
Nice to meet you.
So it's basically a dialogue system that we can collect data with in Mechanical Turk. So people can just click on the link and they will stream the video from your webcam into our server. So we already expect that it's going to be a very, very varied data, but it's going to be a lot of data. So we can do selections, we can do other things. And we can adapt it to other different tasks that people are interested in for different research hypotheses. So this is our interview training purposes. Apparently never applied for a job before. So other people who are like me can benefit from the system. So after all, I want to say is my job, my research purposes is that empowering the dialogue system with more social capabilities that is able to use multimodal information to adapt to user behaviors to make the dialogue more natural, more effective. So actually, we want to turn theory into semester in curve. So it's a long way to go, but I think we are making contributions towards that. So thanks again for inviting me, and please, if you have questions, you can contact me. This is a TikTok. Hope you remember him. Okay, great. Thank you. Okay, questions?
So for the space station dialogue system, we absolutely killed ourselves to get 185 millisecond response time. Because if you later, if you wait long enough, people get confused. Did they get it? Should I say it again? All that sort of thing. So going to the cloud is going to be the killer.
So we are moving the system to EC2, so Amazon EC2. It's more about the, yes, the streaming is going to be a problem, but we can probably use more computing resources and network things to make it better. So right now it's okay for me to actually carry on that conversation. It still has these latencies. We can use strategies like or something like that to signal that we're holding the floor. We don't need to speak. I'm syncing, but still that it's a real problem, and the bottleneck is in the network people.
Well, we actually have the communication protocol in the middleware to make it better.
So, yeah. I think they're actually, because of these advanced technologies in networking and parallel computings, and also the Google ASRs, we can actually do these in a better way. So it's moving forwards to that direction.
Do you have thoughts about when you're about moving from engagement to more task-oriented? So even if it's task-oriented, you want engagement. Yes. But like, you probably don't want a strategy if it's changing the topic.
Oh no. So yes, definitely. So the reason we were doing this social chatting is something that we want to say that how can we actually study the behaviors in the social chatting? Definitely the strategy. Some of them are applicable for certain tasks. Some are not. It depends on your task. You need to design different strategies. And definitely this engagement is very complex. You have task engagement. You have social engagement.
Right.
So if you're studying them together, it's kind of hard to tell the difference. So we're trying to study one thing first, and then we can merge them together. So definitely when people do this task-based dialogue, what people are doing is that we open up the conversation with some of the, we ease some people in the conversation. We first say, how are you doing? Blah, 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 blah. And then we also, in the middle, we're going to say, do you want some water or something like that? These are all social things that you can do besides the text to improve the connection between the human, to make the human feel more comfortable, more pleasant in talking to you. So definitely, these are like a social processes that humans have behind the brain during the conversation. And it's really hard to bring them in the front. So we're trying to constrain the domain first, and then we're moving forward. Okay. Thank you so much for coming and listen to my talks and give me a lot of good feedbacks. Thanks.
Thanks for listening.
Thank you.